I repeat, let me introduce you to the report on the topic on one approach to building a temporary model on the knowledge base. I am associated professor of the Department of Information Systems of Simon Kuznets Kharkiv National Economic University, Volodymyr Burdaiev. Main topic of the report, chatbot, online consultation and expert system. The main idea of the report, online consultation for the expert system is integration of the Telegram chatbot and the carcass system. Consider dynamic rules, knowledge base for expert system based on the idea of the bundles, the knowledge base. The concept of constructing knowledge base models based on a hierarchical functional system, and it is implementation for integrating chatbots with expert systems is investigated. Messengers can be viewed as a specific type of browser, and the chatbots can be viewed as web applications with elements of artificial intelligence. And bots will get commercial value only if they leave the entertainment industry. The next is topic QA system. A chatbot can be thought of as a question and answer system with elements of machine learning, namely natural language, parsing functions, and inference engine, and a model for communicating with external applications. Expert system. In the traditional approach to the implementation of the interface, expert systems use limited natural language of various graphical controls. The images of chatbots allows you to use a language interface. The paradigm for integrating chatbots to work with expert systems is now becoming more and more relevant. The carcass system provides tools for creating knowledge-based models. The ES economy carcass bot is chatbot has been created the Telegram messenger, which is integrated with the carcass system. ES economic carcass bot is intended for a consultation with prototypes of expert system in economic and financial topics. In the West, you can use a bot to conduct online consultation with an expert system. The message from the chatbot command help is shown on the slide. Functional system. Our functional system is a system format to achieve a given useful result on the course of its operation. What is the problems? Firstly, construction of mathematical and computer models. Secondly, integrating a chatbot on the Telegram of Messenger with a shell for expert system carcass. Models of open or living systems. A distinctive feature of FSS is their openness, not autonomy, not isolation from the external environment. The mathematical model describing the evolution of such systems are non-autonomous differential equations. To study the topological properties of a non-autonomous equation, the mathematical apparatus of extensions of dynamical systems based on the concept of a bundle is applied. On original approach. Representation of dynamic subject area in the form of a hierarchical FS, in which the knowledge base is associated with a chain of bundles for evaluation of its main goal. At each level of the IFSS hierarchy, layers of the knowledge base bundle chain contain knowledge for managing it in order to achieve a specific result. The subject area, there are classes and relationships between them and form the structure of hierarchical FS. IFS allows you to generate at discrete moments changes in the objects of subject area. The mathematical models of FS. The not quite strict definition of the extension of dynamic system is represented by the model 1. Let us describe the model 1 in terms of global analysis. The triple of objects and PB forms a bundle where P is continuous mapping, it is projection. B is base of the bundle, M in index, slow index B is the bundle
Sorry,
layer.
we have some limits of time. You have 2 minutes for, because
thank you.
Okay, it's very interesting, but we have some limits. Maybe the main goal and the main message and maybe the efficiency of your work. Thank you.
Thank you. The architecture of integration of the chatbot with the system carcass is shown on slide. Other approach to modeling IFSS and dynamic knowledge, the use of temporal knowledge in integrated expert system, simulation of a dynamic intelligence system, using a fuzzy temporal graph, open multi-agent system with self-organization, hierarchical stability of biological communities. Thank you for your attention.
Thank you for your research. If you have, our participants have some question, you can ask. Maybe I will be the first. I have one question about, I understand that it was Telegram technology of chatbot, and why you choose this technology of chatbots, maybe not chatbot by neural network, or not your own chatbot, why you prefer to use the Telegram and maybe to carcass system.
Thank you. I will think about your question.
Okay. Any other questions from the audience? Maybe if no, we can go to another speaker. It's Gennady Shepelev and Nina Khairova. You can start. Volodymyr, you can switch off your presentation and Gennady, you can start. You can share your presentation.
Do you see my presentation?
Yes, we see your presentation. You can put F5 to see all screen.
Let me to introduce our work, collective risk estimating method for comparing polyinterval objects in intelligent systems. Interval automatons are such objects of comparing whose quality indicators are represented as interval estimates, both monointerval or polyinterval, due to uncertainty. We recognize among polyinterval objects fuzzy intervals, fuzzy automatones, and general interval automatones. The essential feature of such comparing is inevitability of risk of making wrong decision. It means that you take into account on equal basis two criteria of comparing, criteria of preference and risk. And we distinguish two types of risk. Risk as a possibility of losses and the risk as dangerous of making wrong decision. Two types of risk, two methods of comparing. Now we will discuss method of collective risk estimating. Here, the preference indicator, here is risk indicator. And now we will apply this method to comparing of fuzzy automatones. To do so, as usual, we should use the classification procedure. The first procedure, the second procedure, but we cannot at once integrate this formula because area of integration is divided on sub-domains. And these functions depends on configurations of compared alternatives. Here are these configurations. Points alpha is limits of integration, and we may now integrate previous formula, and for configuration 1, we receive such relation for the first configuration by first procedure of identification. It's for the second procedure. And we did it for all configuration mentioned above. Now about general interval automatons. Here we cannot use previous approach because this comparing is realized not for the same alpha level, but for different alpha levels. And to overcome this difficulty, we propose procedure by means of which we may transit from poly estimate to single, to mono estimate. And we use for it procedure of probabilistic mixture. Here's an example. This procedure for the case of all uniform distribution on mono interval forming poly interval, and the same for mixture function. Now we should receive an approach to compare mono intervals with different and arbitrary distributions. To do so, we may show full fields of events in theoretic probabilistic sense on two-dimensional plane with axis interval 1, interval 2, and then select from these events such ones which favor to tested hypothesis. Let's say the second interval over the first one. And then in this way, for the first configuration, we have such formula. We may take this integral, double integral, by means of fusion procedure, including analytic part and numerical part. And we may apply this approach to all configurations. These are our results. One may add that this result may be used in intellectual computer system, intellectual decision support system. And here are possible further studies. Thank you for the attention.
Thank you for your research. If someone have any question? No. Maybe I have one question. Maybe when we compare it with another research, the speed of these methods is better, or maybe no, because I don't understand from the effect.
Thank you for the question. Of course, there are a lot of methods of comparing, especially for comparing of further intervals. There are more than 30, maybe 40 methods, but they are specifically for comparing of fuzzy objects, fuzzy alternatives. And besides, this method contradicted each other. For the same pattern, for the same data, they give different results. Besides, we would like to use and to invent some methods which will be universal, because in practice, we may strike with different situations. Compared alternative may be with mono-interval quality indicators, poly-interval, and point deterministic. And we should compare the result received. And besides, this result should be obtained by the same method. And this used method which are to some extent universal. Thank you.
Thank you for such full answer for my question. Everything is clear. The second our speaker is Igor Shubin, or did we have the speaker here? Development of conjunctive decompression tools. Okay, Dmitros, then we will be maybe looking for Dmitros Sitnikov, Polina Sitnikova, and Andrei Kovalenko. No. Interesting. Okay. Oleksii, Kudryk, Oleg, Bisikalo, Yuliia, and Oleksii and Serhii radio.
Hello.
Oh,
I'm Oleksii.
You're Oleksii Kudryk, and your research about intelligent information system for predicting chemicals with interactive possibilities.
Yes. I want to show the presentation.
Yes, share your presentation. You have 5 minutes for your research and 3 minutes for question. Thank you.
Do you hear?
Yes.
So, hello. I want to say about my topic again. The topic of work is intelligent information system for predicting the chemicals with interactive possibilities. Currently, compounds of rare earth elements with tetrahedral oxyanions like phosphates, vanadates, silicates, arsenates are being intensively studied. This is due to their use in the manufacture of materials for phosphors, lasers, LEDs, displays, and tomographs, and for disposal of various radioactive wastes, including nuclear reactors and dismantled nuclear weapons. As the service life for aluminum phosphate or borosilicate glass used for these purposes is only 30-40 years. The purpose of study is to develop a model and intelligent information system for predicting chemicals with interactive possibilities, which provides data reliability, high speed, and ease of operation. There are 2 ways to predict the limits. First, by experimental studies, however, that will require the cost of expensive reagents, equipment, and will significantly increase the duration of research. And the second way is by calculation methods that does not demand big expenses of means and time. For this purpose, we have created a program for predicting the limits of substitutions by the crystal chemical method in systems with isostructure components in the approximation of regular solutions. The main task of the method is to determine the mixing energy of the components Q, the knowledge of which allow Baker's equation, setting the decay temperature stability to calculate equilibrium composition of solid solution X, or for given X to calculate decay temperature. The scientific novelty of the model is that mathematical model for predicting the phase stability of solid solutions has improved, which in contrast to the well-known Ursov model calculates the exact rather than the general critical decomposition temperature in terms of approximation of regular solutions. Before this system can work, it must be filled with data. Data for system were taken from various scientific sources, both modern and fundamental, which were published in 1930 to 1970. The data set is very large. Oracle products were used in the development of information system. This slide provides interface for predicting existing systems. First, you need to select the structure, system, variable underneath, epsilon, and click button calculate. And we will have the graphic and the table with results. Here we can see the interface for calculations arbitrary system. Here you should choose the structure, constant underneath, changeable underneath anion, step, and click button calculate again. And we will have the graphic and the table. To calculate the limits of substitutions, decomposition temperatures, and assess the stability of solid solutions, it's necessary to know the parameters of interaction, mixing energy of solid solutions. There are several theoretical and experimental methods to determining them. During the period 2007 to 2070, they were repeatedly used to calculate the interaction parameters in phosphate systems. Comparing the result with previously known calculations for europium and gadolinium, we can conclude that our mathematical model is reliable and the information system created by us provides quite accurate results for such systems. On this slide, you can see example of interface for entering thermodynamic systems and elements that apply to each respectively. Here you can see the basic applied year database model. Here selected the main tables of this application, like atom length, atom length, volume cell, structure solid, and etc. So develop intelligent information systems that are reliable, appropriate, ambulance, convenient, effective, and universal for practical use by material scientists. Scientific and technical result of the study. First time, intelligent information system for predicting chemicals with interactive possibilities was created. The knowledge base is based on advanced mathematical model of prediction, which allows to increase the accuracy of mixing energy calculation and calculate accurate rather than total critical decomposition temperature. Through the application of JavaScript, HTML, PL/SQL technology, such functions of the system as providing remote access to work with the system, input and storage of initial data, visualization of predict results have been software implemented and experimentally tested. This based on the study and construction of easy to operate IIS, the accuracy of predicting the phase stability of solid solutions is increased. At the same time, the created IIS allowed to abandon experiments with dramatically increases the speed of forecasting by several orders of magnitude. So thank you for your attention.
Thank you for your research. If someone have any questions for speaker. Maybe I will have one question about your last slide, and there you have the metric values. You have published result in the range 66%, yes. And what about calculation of metrics of efficiency of this work? Maybe precision, recall, or something like this in comparison with other software like you. And what about the high speed of your software?
This system is first in chemicals of predicting. We don't have any analogies, so it's first.
It's first system.
Yes. Before this, were a lot of experiments, and chemicals spend a lot of time to do this, about months. And here we can go to the system. I want to change the slide. For example, this. You can open the page in your web browser, choose the structure, the system, what you want, variable lambda and epsilon. And after this, only click the button, calculate, and you will have the results in table and the graphic. And it's very speed before you spend a few minutes. Before this, the chemicals spent the months, and it was very expensive.
And what about speed of your system? What is about your technology? Because about the technical part. About
I use Oracle products like Oracle Application Express and database Oracle 2, the PL/SQL developer. And the stack of front end is JavaScript, CSS, and HTML. and back on PowerSQL.
Okay, understand. Thank you. We have only 5 minutes. So next it was next speaker is maybe will be in the next section. And if you can now, we will switch off we will interrupt it, and you must go to the link from the program, and I think we will start from that link. So in 4 minutes, we will go to the main link, and our main speaker, Olga Kanishcheva, will set us to go to the same link, to my link, or something like this. So we have 5 minutes, and we will go to main link. Okay?
Okay.
Yes, thank you.